Hey there, OChemNinjas. Today I want to talk about the rules for drawing valid resonance contributors. Resonance is one of the first concepts we learn in organic chemistry, and it's often one of the most historically confusing for students. It's a good early test of how you're transitioning from Gen Chem to OChem. So if we have a molecule such as this and we want to draw resonance contributors for this, what are the rules for drawing those resonance contributors? What are the rules for knowing whether the next structure you draw is a valid resonance contributor of the original? Now, this isn't a video on how to actually draw the resonance contributors. I have a separate video that I'll link to down below for that. This is just a video for knowing whether the next structure is a valid resonance contributor or not. So let's jump right in. The first rule for drawing resonance contributors is that only lone pairs and pi electrons can move, and the sigma bonding network must remain the same. The reason for this has to do with conjugation. Resonance is based off of conjugation. If you're not sure you fully understand conjugation, make sure you watch my video describing conjugation that I'll link to down below. So a structure like this is not a valid resonance contributor for this molecule. This molecule has broken the sigma bond between carbon and hydrogen, and we're not allowed to break sigma bonds in resonance structures. Only pi bonds and lone pairs are allowed to move in resonance contributors. The next rule is that you must have the same number of unpaired electrons, of radical electrons, in the new structure that you draw. In this next example, the pi bond is broken and we've have two radical electrons on the oxygen and carbon. This would not be a valid resonance contributor because it has a different number of unpaired electrons. We started with 0 radical electrons and we ended with 2 unpaired electrons. Now, you can draw resonance contributors of molecules that contain radicals, but they would start with the radical from the beginning and you would have the same number of radical electrons throughout the resonance series. Third, and I hope this goes without saying, the molecule must be a valid resonance contributor. We can't break the valence rules of organic chemistry. This molecule is not a very good molecule at all, and it is certainly not a valid resonance contributor. We have 5 bonds to carbon and 2 bonds to hydrogen. Carbon only makes 4 bonds and hydrogen only makes 1 bond, so this cannot be a valid resonance contributor because it's not a valid Lewis structure. A corollary to this rule is that we also must have the same number of valence electrons that you started with. That's also one of the rules for drawing Lewis structures. We only get a certain number of valence electrons in our molecule, and we have to keep that number of valence electrons the same throughout. In this molecule, I've actually added an extra set of valence electrons in order to make that pi bond, so this is additionally a reason why it is not a valid Lewis structure. The final rule in this list is that the resonance structure must have the same net charge. This is a really important one, a really nice check your work tip to keep up your sleeve. That makes this molecule an invalid resonance contributor. It is not a valid resonance contributor because it does not have the same net charge. We started out as a net -1 charge, and here we are at a net -3 charge. This molecule is also an invalid resonance contributor because it breaks rule number 3. It's not a valid Lewis structure for this molecule. We have changed the number of valence electrons that we started with in this molecule. I've added a new set of valence electrons for the new lone pair on carbon. So these are all the rules for figuring out if the next structure is a valid resonance contributor, but we still haven't quite figured out how to draw the next resonance contributor. For that, we're going to need curved arrows, and we're going to learn how to use those curved arrows to draw valid resonance contributors. I have separate videos on each of those topics that I'll link to down below. Resonance is a tricky concept for beginning students, but knowing how to evaluate these structures is one step on the way to becoming an OChem ninja when it comes to resonance.
Thanks for joining us today, ninjas. Be sure to watch these other videos to level up your ninja training even more. As always, don't forget to like and subscribe.